we just do the same thing?
Guys, look.
Multiply it by 2.
There you go. It's an even function, right?
How do you?
So it's going to be.
So it's 2 times the first one we got.
Yay. 2 pi plus 5.
So 2 times pi plus 5 over 2.
Indeed.
2 pi plus 5 is correct. Think smarter, not harder.
I said times 2.
I know. I did, and I said yes.
That's a 0 equals 5. Which you just know.
Ooh, okay.
This is an F.
Okay, that's a capital F.
That's F prime.
Yes. So, no. That's the antiderivative.
Okay.
So the antiderivative of f at 0 is 5. That's what that's saying. What is the value of f of 3, capital F of 3, where f is the antiderivative of f of x? So, since you have the numbers for antiderivatives 0 and 3, we do the antiderivative from 0 to 3. Makes sense, right? And we know that that would be the antiderivative, which is the big old f of x, evaluated from 0 to 3, right?
So we would just take the first equation we have.
So it's f of 3 minus f of 0. F of 0 we found, or we have, it's 5. F of 3 we don't know, but we do know what this is, and that's what you were saying, Faith.
Yeah.
Right.
That we found in the very first box.
Pi times 5 plus 5 over 2.
Pi plus, 5 over 2.
The extreme addition.
So add 5, which is 10 over 2. You get f of 3 is pi plus 15 over 2.
That's what I'm going to start calling it. The extreme addition. Because am I wrong?
Yes.
No.
The next one. It's given to us f of big F of negative 2 equals negative 2. What's the value of big F of 2? So how are we going to start that off?
It is going to be f negative 2 minus f of 2.
Right, it's the antiderivative
I got that.
from negative 2 to 2
Was it?
of f of x dx equals big F of x from negative 2 to 2. So that's f of 2 minus f of negative 2. Did we already find that somewhere?
We got 0 to 4.
Yeah.
But
And we
0
have
to 3.
negative 2, which
Or
is
negative 3 to 3. Or
Okay, so no, we don't have it all. So
No.
we got to find it.
sad.
Okay, that's no problem.
No, it isn't a problem.
It is not a problem.
From 2 to
Big
negative.
problem.
So we're finding it from
2 to negative 2 to 2. It's the
negative.
weird one. Of course it is.
No, it's a rectangle and a half circle.
There you go.
Think about it positively.
So the rectangle would be 1, 2, 3, 4
Do we technically have the circle?
times 1. Well,
Can
we
we
have
just times the corner
a
by
semicircle.
Do we have it though?
To be honest with you, we could just multiply the circle and the that we got already, and the rectangle we got by 2.
That is true.
Can we just do that?
Yeah. The radius is 2,
Yes.
so that would be 2 pi. So it's 2 pi plus 4.
Teachers, excuse interruption. Seniors last name I through K. Brown's graduation is here. For cap and gown, report to the commons area. I through K.
f of negative 2, notice, is negative 2. So this is f of 2 plus 2.
F of 2 is equal to 2
So
pi.
subtract 2, f of 2 is equal to 2 pi plus 2. I'm going to keep going, but the free response questions that these are practice, I will teach those on, and just have you copy the notes and blah, blah, blah. All right, so on the free response question, it's a practice one, great practice. Let f be a function defined on the closed interval negative 3 to 4 with f of 0 equals 3. That's important to know. That's an initial condition. Anytime they give you one of those in a free response question, I would circle it or something so that you remember it's there.
3 is not even on the graph.
It doesn't have to be, because this is a graph. That's something else you should circle of f prime, not f. That's the next statement. The graph of f prime, the derivative of f, consists of one line, one segment, and a semicircle as shown above. On what intervals, if any, is f increasing? So this doesn't even have anything to do with what we're doing right now. This is just, hey, let's put it all together.
From
Negative 3 to negative
0 to 2.
Okay, 0
No.
to, that would be the slope of the derivative. I'm trying to find where f is increasing. Would you say?
Negative 2.
Yes, negative 3 to negative 2, because it's above the x-axis. So that means that f prime is positive, and when f prime is positive, f is increasing.
This is why I'm going to fail the test.
Since f prime of x is greater than 0, from negative 3 to negative 2, then f of x is increasing on negative 3 to negative 2. B. Find the x-coordinate of each point of inflection of the graph of f on the whole interval, negative 3 to 4. Justify your answer.
That would be the max and mins on this graph.
This is f prime. So points of inflection would be, yes, maxes and mins. So we have a max here at 2 and a min at negative 2. So we can write that as f of x has point of inflection when, because we have to justify, when f double prime of x changes signs. So that means the slope of f prime of x changes, which is why we're saying maxes and mins. If f double prime of x,
Teachers, excuse interruption. Next group will be L through N. This is for seniors. Report to the Commons. L through N.
I'm just finishing writing this one out. It's what you said. So if f double prime of x changes signs, then the f prime of x has a relative max or min, which occurs at x equals 0 and x equals 2. So those are points of inflection. Because it's changing slopes, so changing concave up, concave down, concave up,